Hello and welcome to Econo Insight. This video will cover Bayes' theorem, but we will directly delve into a numerical example and try to solve it because Bayes' theorem is actually kind of straightforward. The name is kind of daunting at first, Bayes' theorem, but it's kind of intuitive. So, in this question, let's solve question A first, letter A. So, letter A is straightforward. What is probability that a randomly selected adult is 65 or older? Guys, by the way, feel free to stop the video anytime you like to read the question more clearly. I'll just go on directly. So, let's see. In here, we can see that the 18 to 64 age group accounts for 83.5% of the adult population. So simply, 65 and older is just 1 minus 0.835, which is 0.165, right? So, or you could put it in percentages, up to you, depending on your mood. So yeah, 16.5%. So that everyone can do. Now, for B, then we go into Bayes' theorem. Given that an adult takes prescription drugs regularly, what is the probability that the adult is 65 or older? So, to give you guys an idea of what is going on here, first we should draw a tree diagram. I'm sure you guys are all aware of a tree diagram, or else learn that first. I'm telling you. So, let's go. Now, for 65, ages 65 above, let's actually do that with 65 plus. It has a 0.165 chance of happening, and 64 below is at 0.835, I'm sorry, and we'll just branch it out. That R is denoting the one who takes the prescription drugs regularly, and R complement is the people who do not take prescription drugs regularly. So that is 0.82, 0.16. Note that I am just plotting the information from the one that's given in the word problem. So it's best to know what you're dealing with first. So yeah, just pan it out like this, okay? So now you got an idea of what is going on here. And the question is asking, what is the probability that an adult is 65 or older, but given that an adult takes prescription drugs regularly? I'm going to tell you how first. So I'm sure you guys are familiar with the Bayes formula directly. Some people will just plug it into the formula, but I just want to tell you how the formula is actually derived, so you kind of get an intuitive sense of where all this is coming from. So what we are finding is what the 65, but given R, this is what we're finding. And based on the law of conditional probability, this is the conditional probability actually, it's simply 65, this one, then over the probability of R, right? So what we're missing is here that there are some things that we can't find here. For instance, this we cannot find here, right? So that's kind of hard because, that's kind of hard. So what we do is we flip it. We see it from another angle. So what we have now is this. Given that it's 65 older, how many is taking prescription drugs regularly? So that formula for that is simply by conditional probability also is this, right? So now we observe similarities here. Some people might miss this, but notice that the numerator here and the numerator here is actually the same thing, right? So we could actually sort of manipulate the equation here by substituting. So I'm going to copy that. I'm going to move it to the next page. So that's very important for you guys to notice this bit here. It's actually the same. So what we do then is that, as we know, we what do you call this? Manipulate it a little bit. So this, the numerator is actually equals, which is multiplied by, okay, right? So this, we plug this equation here, this thing here to the first one here. So let's do that now. So if you guys want to skip through the workings, you can just skip through the video because I'm just going to be jotting this down here. So this is the numerator as we have found from the other equation, because again it's telling the same thing. And now we have here the denominator, which is the probability of R. The probability of R is actually simple. If we go back here to our tree diagram, is simply this and this here, right here. So that is the probability of 65 multiplied by this plus probability of this multiplied by this. So let's plug that in again to the formula. So it's 65 plus then multiplied by PR given 65 and plus the space not enough there, so I'm just gonna word it downwards. Again, if you want to refer to any of these notes, I have a lesson note down below in the description box which you can actually access. It's way neater and it's systematic. So there we go. So this is our equation. This actually, if you compare to the base equation that people give you in the formula sheet, it's actually the same thing. But how do we get there? It's through this process. So I hope by doing this, it helps you make it intuitive, break it down, sort of absorb it. So now let's just plug in the numbers, which is 0.165 multiplied by 0.82 over 0.165 multiplied by 0.82. Don't forget to put brackets. Brackets are your friends. Remember that. Multiplied by, this is a multiplication sign, don't forget. 835.835 multiplied by 0.49, and there you will get approximately 0.2485. So that is the answer for B. So given that an adult takes prescription drugs regularly, the probability that an adult is 65 or older is 0.2485. So I hope this makes you understand what the base theorem is, and most importantly, break down the formula, how the formula came to be. So this is the process of how the formula came to be. Don't forget that. It makes it intuitive for you. I hope it helps. Thank you.